Hello, everyone. So today we have a very interesting guest with us. So today we have Pulkit. Pulkit is an ex-SWE at Google. So interesting fact: me and Pulkit both joined Google almost at a similar point of time, and we have been knowing each other for a long period of time. We taught together at multiple places, and I know Pulkit as one of the finest SWEs like in the recent times that I have met. And I didn't get a chance to work with him at Google, but I definitely can see he did some really great contributions at Google altogether. So first of all, welcome Pulkit to the channel.
Thank you so much.
Cool. So today we'll be having a mock interview. We'll be keeping it kind of like an algorithmic problem solving mock interview. And we are going to keep it very similar to that of the format of Google, in which we will be having 45 minutes. In 45 minutes, we will be focusing on algorithmic problems. I'll be giving you a problem to solve. We can discuss the approaches that is coming to your mind, and probably we can code it. And if the time persists, we can maybe solve one more problem or a follow-up question altogether. Make sense?
Yeah, that makes sense.
Cool, cool. Let me share it. Okay. So let's just start. Let's just start. So I'm pasting the question here. I believe you can spend some time in reading the question. Okay.
Okay.
And
Okay.
let me add up a few more details on the question.
Okay. So given an M cross N grid, each cell of the grid has a sign pointing to the next cell you should visit if you are currently in this cell. Okay. If the sign actually R means that you have to go to the right. Okay. L means you have to go to the left. D means to the but okay, and U means to the upper cell. Okay. So there is a proper path that we have to follow. We will initially be at the 0, 0 cell. A valid path in the grid is a path that starts from 0, 0 and goes till m minus 1, m minus 1. Following the signs on the grid, the valid path doesn't have to be the shortest. Okay? Like, in whatever you have pasted so far, it seems to me that I really don't have much of a choice. Like, if I start at 0, 0, I just have to follow. Like, there is only one option that I have from each cell, which is, basically dependent on the character that is written on that particular cell. So, uh, I don't see what can I do here. Yeah,
Makes
I'll
sense.
either end up reaching m minus 1, n minus 1, or I might, end up in a loop or something else where I just don't reach anywhere.
Got it. Got it. Can we look at some examples that we are following at? Like, can you maybe draw a similar situation and walk me through like what's the solution that you're thinking about? Like you mentioned that you don't have much of a choice, so let's maybe start a discussion based on a example
So,
altogether.
so see, my point is like, what is the question? Do I just have to like tell you if there is a valid path or not, or like
Yes. So the expectation of the
okay,
problem is that you have been given a m cross n grid.
yeah.
Each cell of the grid has some character that points to the direction
All
whatsoever,
right, I
right?
understood. So I just have to tell whether
Yeah.
a valid path is there or
There
not
is a
because I did not
valid path
understand.
from top left to the bottom right or not.
Okay, I just have to give
That's
a
it.
yes or a no if there is a valid path
It's
or
a
not.
it's a boolean answer. It can be a
Yeah,
boolean
yeah.
answer,
So in
yes or no.
that case, so I did not understand the problem clearly maybe earlier. Now I understand. In that case, I can see that from cell ij, if the character at that cell is r, then that means that in a way we can directly go from ij to ij plus 1, as you are saying, right? Similarly, if it's l, we can go from ij to ij minus 1 and so on and so forth. So basically I can visualize this whole grid as a graph where I believe depending on what is the character at the cell ij, there will be exactly one edge. There will be exactly one directed edge from cell ij to either ij plus 1 or ij minus 1 or I plus 1j or I minus 1j. So this will be a directed unweighted graph that I'll sort of form, and I can just do a BFS from 0, 0 to find if the cell m minus 1 n minus 1 is visitable from there or not. That is the idea. Yeah.
Got it. So what will be the space complexity of the solution if you are going to visualize it as a graph, and like probably if you're thinking in
So
terms of BFS, what will be the space
yeah.
complexity that we're looking
So
at?
see, the number of nodes in that graph will be, I'll just write it down here. The number of vertices in the graph will be approximately equal to n into m. I think exactly equal to n into m. and the number of edges in the graph as well, because from each node there is one directed edge. The number of edges also will be approximately n into m. So for BFS, we know that time and space both time and space are big O of v plus e. Sorry, not space, I guess. Time is big O of v plus e. In any case, either it is big O of v plus e or it is big O of v. In both the cases, it will be big O of n into m.
Both time and space.
Yes.
Okay, cool. Do you think we can optimize this somehow? Maybe in terms of space, if we
Space.
can optimize something.
Okay, so want me to try to optimize on the space somehow. All right, let me think. So, time you're fine with, right? Time of n into m you're
We
fine
can
with.
see if you have like I believe the time you have given as n into m. That's kind of like a bare minimum.
Yeah,
I believe we will
yeah.
definitely need. Otherwise, we might not even read a lot of cells. But space is
Hmm.
something that I'm concerned about.
Hmm. All right. So here, see, in BFS, what I am trying to look into is that uh, it is like a 1 inch from each. So, so see, the idea that I had was that I'll have a 2D vector that will be like visited, whether this cell is currently visited or not. If I
Makes
end up
sense.
making that 2D vector in case of BFS, then I have used my n into m space then and there only, correct? So that
Yep.
means instead of using a 2D vector, probably while doing my BFS, I will use something else, which is maybe an unordered set or an unordered map or something of that sort, which only stores those nodes which are visited. That is the idea that comes to my mind right now. Number one. Number two, I'm just trying to analyze whether doing a normal BFS uh, by just tweaking how I'm storing the visited cells, will that help me reduce the time complexity? That is what I'm thinking right now, because it might be the case that by the time, so basically because the maximum path length from one so yeah, that is what I'm not able to kind of understand, because uh, hmm. So in BFS, at one point, the maximum number of in BFS we kind of generally go in increasing order of their distances, right? First it
Yep.
is distance zero, then distance one, and distance two, and then so on and so forth. So if I want to in my queue, I can have it in that manner that at a time. In a way all those nodes are present uh, which are kind of like part of the which are kind of at that particular distance, number one. Number two, if you let me reuse the grid array which is given, if that is something that you are uh, saying is mutable, then I can use that grid array to somehow maybe reuse that as a visited array as well. That is what I'm thinking.
Okay. So you're saying that the given input metrics that we have, if we can reuse that for the visited perspective instead of having a different set or a vector,
Yeah.
then we can optimize our space. But maybe, like, let's say that we cannot mutate the metrics. Like this matrix is expected to be immutable. How about that?
All right. Okay. So up from up and down. So basically, what I'm thinking is that in the worst case scenario, see, if I don't have anything in my hands, I am able to think of a case where in worst case scenario, let's say it is like a snake-like structure. For example, if I kind of try to draw it here, are you
Hmm.
able to see my XLE draw?
Yeah. Yeah, I'm able to see.
Right?
Yep.
So if I kind of look at it this in this manner, let's say this is the grid. So I'm able to imagine a path where let's say this is right, this is right, this is right, this is down, then left, 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 then down, right, 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 then down, then left, 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 then down. Okay, so let's say this was the kind of thing that was given to us. So now in this case I can see that you know uh, to be able to visit this n minus 1 m minus 1, or the bottom right cell, all the other cells would have come in my path. So in this case, even if I keep an unordered set or something to keep track of what all nodes are visited, then also I would have ended up adding all the nodes in the uh, data structure. That means this is still not doing me any good. So let me think about it in a manner that so see, because this is the case, if I do a standard BFS, it feels to me that the worst case time space complexity can go up to of n into m, as we just saw in this particular example. So let me try
Yes.
to think if there can be some other way which is not exactly a standard BFS. uh, all right, I can think of a way. So see, because from one particular cell there is just one option to go to some other cell. So what we can do is we just keep track here also. Let me okay, again I am thinking ki it might still end up in us. So yeah, so I'll explain you the example. I'll explain you the method that I'm thinking, and I'll try to see if I can optimize the space there. But what I was thinking was that every node has just one neighbor only. So as soon as reach a neighbor, let's say I'm going to my neighbor, then I'm from there I'm going to its neighbor, from there I'm going to, I'm all I'm doing is I'm just trying to go to my one and only neighbor. And at each times, if my neighbor is already visited, that means I'm in a cycle now, so I'm not going to come out of it. So from that I'll come back here and keep on going in a cycle. So at
Makes
any
sense.
point, one by one I'll just try to go to whatever neighbor I have, either left, right, up, down. Whenever I revisit a particular cell, then I can be sure that the answer is not possible. And in this whole process, if I end up reaching n-1 cell at any point, then that means I've reached. Then and the answer is yes. But here
Yeah.
also, if I brainstorm, it is still possible now, because I'll have to keep track of the nodes that I have visited so far.
Makes
So here
sense.
also, if I am to implement this solution also, then also in the worst case, I believe n into m nodes might be stored.
Okay, I like the fact that you are thinking in terms of the fact that in what cases you will not end up reaching the bottom, right? That will be the case of cycle. Am I correct?
Yeah, because I'll be stuck in a cycle somewhere in between only.
So can we say that the problem boils down to nothing but cycle detection? That if there is a cycle you cannot reach, if there is a
No,
cycle you can.
I don't think so.
Sorry, if there is a cycle
Why?
you
Because
cannot reach. If
because
there
that
is no
cycle,
cycle.
let's say if there is a cycle which contains this particular node, then also I can reach now. If there is a cycle that contains this node.
Can you
So
give me an example? Like what will be
for
that situation?
example,
Can we
yeah,
take a
for
small
example,
space?
let's say, uh, how do I, yeah, this one. Yeah, for example, something like this. Okay, let's say this is right, 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 down, 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 then left, then up, then right, then right. So here, if you notice,
Hmm.
uh, like I'll start from here, then come here, come here, come here,
Makes
down,
sense.
down, bottom right. I have reached bottom right, but if you see, is there a cycle? Yes, one,
There is a
two,
cycle.
three. There is. This is a cycle, right?
Makes
So I don't
sense.
think it boils down
So can
to
we say that
ending with
along
this.
with the cycle, if the cycle that you have that already has the bottom right and top left in the cyclic path, then we have the answer. That can be a good corner case that we look at.
No, but
Otherwise, if like
here also
hmm,
it doesn't. This cycle doesn't have the top left corner. No? This cycle
it has the
does
top left
just
corner,
have the
right? You
bottom right.
started from the top left corner. Oh,
No, but
like okay, so the
the
whole
cycle
path,
doesn't
like
have.
I'm considering the whole path. I'm considering that starting from the whole path, that at any point of time, like you were traveling and then you reached before entering the cycle or even after entering some kind of a cycle, but you encountered n-1, n-1, then also it can be an answer. So cycle detection is something that you are thinking in the right direction. But the only point that now left is that how can we figure out that whether a cycle is going to bother us or there is no cycle at all, or what's the case. So I believe cycle detection is a good way to think in terms of but how can we
So
do
yeah,
an
I just I
optimization?
just wanna I just wanna keep on going, and somehow if I end up in a cycle, then I'm gonna say no. But before ending up in a cycle, if I am able to reach n minus one, n minus one, then I'm gonna say
Yes.
yes. That is my idea.
Yeah.
But
Yes.
the thing where I am stuck right now that I need to solve for is that how do I do that without using n into m extra space is what you are asking, correct? So how do I do that without storing all the nodes that I visited so far? That is the challenge, I guess.
Okay. Okay. Let me give you a hint. Do you think the path that you have drawn, like in this example also, the path that you have drawn, you are visualizing it with respect to a graph? That's good. But do you think this graph is having a very special orientation, and can we convert it to
Yeah,
a
that
much
is exactly
simpler
what I was
system?
thinking. Yeah, just give me a second. Let me think about it. So this graph is in such a manner that it will be like a, you know, it's it's kind of like this that it's going to start from a node, another node, another node, another node, like a straight linked list kind of thing.
Very good.
It's like a linked list that comes back to one of the nodes in the start.
Yes. So do you think
So
something around this
yeah,
particular aspect will help?
yeah, yeah. So now this makes sense. So now basically, see, because every node, yeah, let me try to think about it. So because every node, uh, so one by one, I'm going to these nodes and all. Now there is a possibility that some nodes are not at all visited because this linked list is very much, it's very much possible that there are many nodes that they are not, that are not part of this linked list. But from the 00 node, this is what the path is going to look like, is what I feel. uh, Now if our n minus n m minus n minus 1 m minus 1 is part of this linked list, then of course the answer is yes, otherwise it is no. I start from 00, I go to one node, I go to another node, I go to the next node, and so on and so forth. Okay, then at some point, see, detecting a yes is done. Detecting a yes, if the answer was actually yes, then it is done. Then we are, we are going to find n minus one, n minus one in our path, and we can say yes. The problem is the detection
The no
in
case.
case there is a no, where there is a no. So where there is a no, how do I decide that this edge is not taking us to a new node, and this edge is taking us
So
back?
can we say that the longest path that you drawn earlier, eventually that is also kind of like a linked list because it has a like a sequential path,
Yeah,
and
yeah,
the
you're right.
current path also that we have is kind of like a linked list. So what we have to probably do is we have to detect a cycle within the linked list. Do you think that will help? Like if we think in terms of this, that we have to detect a cycle in a linked list.
No, that makes sense. You're right. So, yeah, you're right here. So, if we are able to detect a cycle, let me think about it. So, this seems like a cycle in the linked list, but I also have to think that whether it is just about the cycle detection, because the cycle is anyway going to be there. I don't think it is going to be a linked list without a cycle. That is what I feel. Because
But the
uh,
longest path that you draw, there was no cycle, right?
which one?
The previously the grid that we draw, that we were going left, left, left. Oh, sorry, right, 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 right. Then we take a down, then we come left, 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 left. Then we take a down, we go right, 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 right. That's kind of like
This one,
snake
huh?
path. Yeah, the
This
snake
one.
path. Yeah, there is no cycle here, right?
Yeah, here, of course, there was a doubt that I wanted to ask. So,
Mhm.
the left, right, up, down, which is being given, it's
Mhm.
not sure that it will lead to a certain node. It can take us out of the boundary also.
Yeah, yeah, makes sense.
Okay, okay, okay. If it can take us out of the boundary also, then it changes things. Because then, definitely, as you are saying, it is definitely possible that the linked list just ends without a cycle.
Yep.
Yeah, that makes sense. So yeah, so I do have an idea. I'm just trying to clear my thoughts. I'll just tell you the idea that I'm thinking in direction of. The
Yeah,
idea is
sure.
in direction of using a small slow pointer and a fast pointer from the start of, which is 0 0. So there is I don't remember the name of the algorithm exactly. There is this famous algorithm
Hare
that
and
is
rabbit, I
cycle
guess.
detection.
Hare and rabbit.
You start a slow pointer and you start a fast pointer, and then the slow pointer is just going to next and next and next and so on and so forth, and the fast pointer is going to next and something like that, until one of
Okay.
them kind of reaches a node, like it reaches a null node, reaches a node which is like the last node or something. uh, if before that they meet somewhere, then that means there is a cycle in this linked list. So that is the idea. So here, what I was thinking, I'll just give you the idea. I'll just speak out loud my thoughts, so we can start the slow
Yeah,
pointer
yeah,
and the
it
fast
makes
pointer
sense.
from the
This one
start.
makes sense. What do you think will be the space complexity if we use this slow and fast pointer approach?
I believe it will be big O of one, and I believe this time complexity will still be same. It will be O of an into one. So
Makes
I think
sense.
it gives us what we were looking for.
Yeah, yeah, that's what we were looking at. Makes sense, makes sense. Can we just have a quick implementation around it?
Yeah, yeah. So just give me 2 minutes. Let me try to gather the thoughts and speak out loud, and then
Yeah, sure.
so basically, what I'm going to do is, uh, yeah, what I'm going to do is, I'll have a slow pointer and I'll have a fast pointer. Uh, so basically, slow and fast. Until when will I do that? So if I am not able to go to any new node from the slow pointer or a fast pointer, that means no cycle. So if this thing comes first, then that means there is no cycle. And if there is no cycle and I did not see n minus one, n minus one in my whole path, then that means yeah. So I understand that I will do this slow fast thing until either we reach out of boundary. If one of the nodes reach out of boundary, that is number one. Number two, if they meet kind of somewhere. So see, if they meet somewhere, it is kind of going to be like that there was something, both of them
Yeah,
are here, correct? So number one. Number two, if the fast one reaches out of boundary, that means out of boundary, that means again linked list is over. So in both the cases I would come to know the situation. Now here, something that something I think I'm pretty sure about is ki this is not going to be the terminal. Like after this I can't for sure say that whether the answer is yes or no, because it is possible that when we got the cycle, slow would probably be coming like this, and fast is probably has completed one round and reached here. So now, although both of them reached here, but with slow and fast, we have still not looked at all the nodes that were coming in the path. Uh, because fast could have skipped some nodes, and slow just haven't seen all the nodes. Slow has only seen these nodes. Number one. Number two, even in the case if fast goes out of boundary, in that case also fast was skipping the nodes. It was only going to alternate nodes, and slow is somewhere probably in the middle. So I
makes
believe
sense.
some logic has to be done after that as well to completely check that whatever is the linked list that we have discovered, n minus one, like the bottom right corner should not be a part of that. So that part I still need to figure out, but before that I can write. I think I can start the implementation. I think I'll be able to figure that out while writing. Does that make sense to you? Whatever I'm saying.
Yeah, yeah, yeah. Makes sense. Makes sense. We can, yeah, figure it out during the implementation as well. Yeah,
All right. So I'll write it in C++. So we need a
makes
bool,
sense.
uh, you know, path, you know, is valid path, and we are getting a vector of character, I should say, correct?
Yeah, we can keep a character. Makes sense.
So this is the Yeah, const vector of char. Great. This is what we are getting. So now, like we said, we wanna be, so for each fast and slow, what should I keep? I believe I will keep the cell number. So pair of intent, or maybe we can, let me think. So if I keep the cell number, yeah, I think that makes sense. So I'll just keep slow I as 0, uh, slow I as 0, and slow j also as,
We can keep a pair also.
yeah, I was thinking whether to keep a pair or like both of them. That is exactly what I was thinking. So
Lesser variables to manage, I guess.
okay, let's do pair. uh, Slow, I think we can initialize it like this, if I'm not wrong.
Yep, yep, makes sense.
And fast 0 0. So here I need to think, because they are same initially also. I need to run my while loop. So let's do it like this. While something, okay, while something. So this condition I'll figure out. So while basically we are, while fast is something valid, until then uh, we like to go to next. Now to be able to go to next, I believe it will be better if I make a function next, which tells me that after this cell, what is the next cell. That will make things easier for me. So
Okay.
here I will just pass vector of char, like similarly, which will be, because it is passed by reference, so it's not going to take much of a time, like a big O one call. And let's call it pair of intent. Again, let's pass it by const and by reference only, current cell. Okay, so it will return as an excel. So if grid of, okay, again I will make here int I is equals to current cell dot first, and j is equals to current cell dot second.
Got it.
Let me use C++ lingo. Now, if I could use switch case also maybe, but no, I'll just use this. If uh, grid of ij is equal to r, and j is, here I can take the number of rows as grid dot size, and number of columns as grid of 0 dot size. Here I am assuming that the grid is non-empty. I hope that's a valid assumption, because otherwise if I do grid of 0, it will give us an error.
Yeah, we can assume that for simplicity, we can keep
Okay,
that.
so that j plus 1 has to be less than m in this case. You have to go to right, and the right, yeah, it has to be less. In this case I will return I comma j plus 1. If, so I think I'll just copy this and change certain small things. Yeah, if nothing is the case, I'll just return minus one, signifying that we are gonna go out of bounds. Does that make sense? So if it is
Makes sense.
r, then this is the case. If it is left, then j minus 1 should be greater than or equal to 0. In that case, this will be minus 1. Then in case of d, I plus 1 should be less than n. In case of up, and of course here we have to return I plus 1 and j. Here if you return I minus 1 and j, and here the condition will be up, and I minus I minus 1 has to be greater than equal to 0. So yeah, this will tell me that what is the next cell. Okay, so uh, while I will do this, while fast is not equal to make pair minus 1 minus 1. So that is what I'm thinking. Like, while fast is in the range, so until then, what should I do? Let's see. So if at any point slow equals make pair n minus 1 n minus 1. So I am just changing the lingo a little bit. I'm just saying that n is the number of rows and m is the number of columns. So if
Okay.
slow is becoming equal to this at any point, or fast is becoming equal to this at any point, then I can be sure that just return true.
True. Okay.
Otherwise, yeah, for slow, I think it's not that tough. Slow is equal to next of slow, but for fast, I need to take care that because it's possible that next I want to do next of but do I want to do fast is equal to next of fast, but this is not entirely correct because if next of fast is minus 1 then it's a problem. So
Yep.
I'm just trying to figure out how
But
do I
if
handle that.
next of fast is a destination, then we have a solution also, right?
Yeah, you're right. That is exactly what I was thinking. So yeah, I think you just have given me a hint. I was just thinking that I'll not worry about finding it right now. I was just thinking that I might just keep on going until they meet or until they're ending. But you are right. Even in the process, I can like I was saying that these nodes will be missed.
There are jump
So I can
nodes.
just make
There are
sure that
jump
these are
nodes.
not missed in the process
Yeah.
instead of coming back to them and trying to
Yes, we can save some iterations then.
yeah, you're right. So we can do that at any point if slow is there or fast is there. So here I believe make it better. So I don't think we need to check for slow at all. Okay, so instead of checking, I believe we can just check for fast or next of fast. This should be good enough.
Interesting. Yeah.
So because when we are checking for fast and next of fast, so in the first iteration I check for the 0th node and the first node, the second node and the third node. I believe this should cover everything. Does that make sense? So
Makes sense.
fast is equal to or next of fast. Yeah, this should cover all the nodes in the path. So this is done. Okay. Uh, okay. So here, next of now this thing is solved. If next of fast is the answer, this thing is solved. Now I just need to make sure that uh, I need to do it only if next of uh, fast is done. So here I will do that. Hey, if next of fast is not equal to make pair this in this case, if the next exists, then I am going to next of fast. Otherwise, if it does not exist, if I'm at the last node somehow, correct, then I just want to break, because if this is the last node, then that means there is no cycle and we just have to break out of the loop, correct. In that case, I am assigning it an invalid kind of pair. like
Makes sense.
were you able to understand this whole condition?
Yeah, got it. So you are saying is that if there is a valid cell
If next cell
coming
is
up
the valid
in
cell,
the first jump of net fast, then we go
yeah,
to that valid cell and make one more jump. But if there is no valid cell, then we just assign it an invalid value that can eventually terminate the loop. Is that correct?
yes, that it will just terminate the loop in the next iteration.
In the next iteration. Yep. Okay.
Yeah. In all this, if at any point slow becomes equal to fast,
Yes. Okay.
then we will return, because we did not receive our n minus 1 m minus 1 in our whole thing, we will return false. Once we are out of the while loop, because that means there was no cycle, and yet the linked list ended in an invalid cell before coming to 1 minus 1 m minus 1. In that case also we will return false.
Makes sense.
Yeah,
Makes
this makes
sense.
sense to me. I was just thinking about a couple of edge cases. Even if there is a grid of just one cell, like one row, one column, then in that case also it will just work in the first iteration only. And I am checking for this slow fast after making my changes, because I want to check these in this from the second iteration onwards. Because in the first iteration they're anyway equal.
Yeah, we can assume that the like cells are at least of two rows, two columns kind of thing, so
No,
that
no.
you're
Even if it
checking.
is one row, one column, in that case, I believe in that case also, I think this should work. If I'm
Yeah, because
thinking
then
it
it
right.
will become in both of them will go for an
Yeah,
invalid case.
the
Yeah,
fast will become equal to n minus one m minus one here only.
invalid. Yeah, yep.
No, no.
Makes sense.
If it is just one row and
What
one
will
column, then the answer will be
Mhm.
always yes, because we are already at n minus one m minus one.
We can separately also check that, like if it's
Yeah.
a single row, single column kind of a grid, we can have a
So
separate
yeah,
check for that instead of
I
going
think
inside.
yeah, this is the code from my side.
Makes sense. Makes sense. There is a small follow up that I would like to ask here. There is a small follow up that I would like to ask here.
Yeah, here
Let's
I
say
just write
now
the time and space. Time is off and into one,
Mhm.
and space is
It
off.
should be O1. Yeah.
Yeah.
So in the follow up, what if let's say we go to a cell and then we are allowed to let's say change the direction of the cell. Okay, so let's say if at any cell there was R written, you are free to change it to anything apart from R. Like because
Okay,
R is already written, if you want, you can change it to L, D, U. If there
got
is
it.
somewhere L written, then you are open to change it to let's say R, D, U. The only
Got
constraint
it.
is that making a change to the character costs you 1 unit.
Cost me 1 unit. Okay.
Yeah, because let's say there is a grid. So okay, so I'm drawing like I'm writing below your space complexity text. So let's say there was R, R, U, D, L, L, D, D,
So I
and something.
understand the point. So basically,
Yeah,
on the basis of how many changes I make, let's say I make 5 changes, the cost to me will be 5 units. Is that what you're trying
yeah.
to
If
say?
you change,
Because,
yeah, if you change
because
this
if we are
character
allowed
to
to
L,
do,
then it will be
because
one
if we are
unit
allowed to
cost.
do, it will always be possible for us to reach n minus one, m minus one, in my opinion, because we can make according
Yes.
to that. It's just that how
Yeah.
smartly we do that, on the basis of that our cost will change. So
Yeah,
can you
so
please let
what
me
if
know
you have to minimize the cost? What if you have to minimize the cost, that in minimum cost you, if there was already a path, then though there is no
the
point
cost
of
is
making any change, I guess. But if there was no path, then what is the minimum cost that you're going to spend to make a valid path that may or may not be, maybe let's say shortest or something, like you can think about it. But let's say that's our constraint. How will you approach this situation?
so what
Any
is my
thoughts?
target? I need to return the minimum cost required. Is that the target?
You have to return the minimum cost required.
Integer is
That's your
बड़ा
goal.
accurate. Okay. So yeah, I can think of an approach, but the approach that I'm able to think of, that is not big of one space complexity. That is big of
Yeah,
an
space
involvement.
complexity we can burn a bit, I believe.
Okay. All right. So
Mhm.
I'll share an approach with you. So basically, what it seems to me, earlier we were thinking that from one cell there is this one edge to one of the adjacent cells. If it is left, then towards the left cell. If it is right, it's towards the right cell, and so on and so forth. Correct. But here I believe it will be a weighted graph, because if let's say the current cell says left, so then I'll add a edge to the left neighbor of mine, and the cost of that will be zero. The weight of that edge will be zero. Whereas I will add the other three edges as well, to up, right, and down, with the cost of one, because I can just bear a cost of one, right? I can just assign that edge, those edges, the weight of one, and yeah, so it will be like a weighted graph. Now I just need to find what is the minimum cost of reaching n minus 1 m minus 1 cell from 0 0 cell. So
Mhm.
one possible way could be using a simple standard Dijkstra's algorithm in weighted graph, how we do it, right? But there is another better technique as well. Since it is a graph with just edge weights 0 and 1, there is this technique called 0 1 bfs,
Okay.
which is which can reduce the time complexity, because in Dijkstra it will be n plus m into log of n, I guess, but here it
Mhm.
will still be big of n plus m. N plus m I am saying in terms of graph, but in this particular case, it will be n into m.
Got it.
So we can do it by that approach where the time complexity will also be big O of n into m, and the space complexity will also be big O of n into m, because we'll have to store the distances for each of the nodes.
Can we just like have a quick discussion around like what like how will you implement 01 BFS?
Even code it
What
in
is
the
the
10 minutes. I believe we have around 10 minutes. If you want me to, I can try to code it in 10 minutes.
yeah, sure. We can maybe go ahead with that.
Okay. So we need min cost, and we have again a grid. Uh, okay. So this is the idea. So I'm just thinking, how do I, just make the adjacency list in a proper manner? I mean, one way could be to just have a vector of vector of vector of vector of int adjacency n comma vector of int m. Yeah, this is what we can have.
Okay, fair.
Yeah, where each, like, basically uh, adj of nm will be a vector of int. Yeah, but it'll let me do it like this. So vector of int I'll need uh, adj, and I'll just make it of n into m. This would make it a little bit easier. So for adjacency list, it will be vector of int. This will be like an edge which tells ki kiski taraf hai and what is the cost of that edge. That is one way to go about it. Other way could be
So you're
that
keeping kind of like an adjacency matrix, right? Is if
I'm
I'm not
thinking,
wrong.
like, is it an overkill? Do I need it or not? Like I can do it with this DI DJ thing also, but the only thing is, how do I? Yeah, I think that is easier. So what I can do is,
You can like list can be, I believe, in terms of implementation should be easier. You can keep a vector of pair if there's a
no, no,
weighted graph.
int DI, which will be like, so if I go to -1 1 0 0, or it can be like int DJ, which can be 0 0 -1 1. So this will
These are
be
the
char
directions in which you can
direction.
go, right?
That what is the direction? I'll just keep another one. So here, if I'm going -1 0, so that means I'm going up, correct?
Up. Okay.
If I'm going 1 0, that means I'm going +1, I'm going down. If I
Down.
am, this will be left, and this will be right.
Right.
So yeah, I have just the corresponding directions as well. Now I'll just write the code for 01 BFS here only. From this, I'll just come to know the edges, and I'll also come to know the weight as well
This
based on the direction. So here, what is my source node? The source node is 0 0, and for the source node, I can have I think I need a deck of pair of intent. Let me call it Q only. So pair of intent Q. The second thing that I need is vector of int the distance array n comma vector of int m, which I'll initialize to -1 initially. -1 means that nothing has been visited so far. So
okay.
do stuff for the source node. But stuff we'll just say that the distance of the source node is 0, and we'll also push the source node uh, to the deck. So now, while not q dot empty, I will just get the current node as q dot front dot first and q dot front dot second, and I'll just Get rid of the front node, pop front. Now we'll need to go to the neighbors. So for int k equals to 0, k is less than 4 plus plus k, correct? That is the index of this. So I would say that int row, where I'm gonna go, r is I plus di of k, and c where I wanna go is j plus dj of k.
DJ of K.
So of course, if, and also let me do the weight also. The weight will be if direction of k is if direction of k is equal to the grid of ij, then the cost will be 0, otherwise it will be 1. So we'll have the weight also. Now here, if min of r comma c is less than 0, or r is less than greater than equal to n, or c is greater than equal to m, or the distance of r comma c that we have is better than what we are proposing, d of ij plus w, then just continue, we don't need to do anything. I hope
Makes
that makes
sense.
sense. If we are going out of
Yeah,
range or the distance is better than what we are proposing, just continue.
makes sense.
Otherwise, uh, yeah, I think otherwise what we need to do is, uh, yeah, I'll think of this later on. Like, do I need to check the distance here as well? I'll think of this just now. But otherwise, what I'll do, I'll just say that, hey, in 01 VFS, what do we do? That if the weight is 0, we do it as push front. We push front the r comma c. Otherwise, we push back r comma c. So now I think one cell be pushed multiple times in the deck? The answer is yes. I believe it can be, because earlier if we get some worse distance, then we get some better distance. I think it can be. So in the deck, we don't just need to store pair of intent, we also need to store the distance. So I will have to change it to vector int. The distance is 0. So the q distance will be q dot front ka 2. This will be 1. This will be 0.
Zero.
Now here I need to check that if the q distance is not equal to the current best distance, then don't do anything, just continue. That is number 1. So 0, 1, 2, done. Pop front is okay. If it is not okay, now while pushing back, instead of just pushing r and c, we also need to push uh, d of r c and d of rc, and of course before pushing d of rc, before pushing I will update d of rc as d of ij plus. Yeah, so this is the idea. And of course there could be a way key we just check if ij is becoming equal to n minus 1, n minus 1, we could return it then and there as well. But I believe it is a better practice to return it in the end and not inside the while loop. So here I will just return d of n minus 1, m minus 1. That will be like, that will be better in terms of time. This is just better in terms of coding practices.
Got it. Makes sense. Makes sense. Yep. Looks good. And the space complexity here we are looking at is
Yeah, the time here will be big O of n into m, and the space here will also be big O of n into m.
makes sense. Makes sense. Cool. Yep. I guess that solves the major agenda that we had, right?
Yeah, yeah. Good
Yep.
to, yeah, I think we were able to solve two problems.
Yeah, I guess we are on time. So yeah, thanks, Pulkit. Thanks for joining. And I believe we had a good discussion on the problem and the approach we had. Thank you for your time. And
No, but
yeah,
now as an interviewer, you're supposed to give me feedback now.
I guess the feedback goes after a day. But I believe, I guess we can have a couple of things in the feedback. One thing was, I believe. the part of the fact that the path of the grid can go outside the matrix as well. I believe you could have thought about it very easily earlier also, but I believe
Okay.
the simplicity of the question was kind of like based on the simplicity of the question. Maybe you didn't go in that direction. I believe if you would have thought about that thing, then eventually realizing that it's a linked list and eventually realizing it's a cycle, that would have been like very simple for you based on the implementation that you have got given. Because the moment you realize that it's a 0 1 bfs for the follow-up, I believe you had the solution like right on the top of your mind, and your solution looks clean also. I believe the solution is pretty much clean and pretty straightforward, and most of the time I believe you were able to communicate your thoughts also pretty good. So yeah, and I believe there can be like one more alternative approach also for finding the existence of a path or not for the first question. That like the longest path, like I'm thinking out loud, the longest path that can be there can be starting from the top left, making a snake kind of like pattern that you draw, reaching to the bottom right. So in the worst case, how many cells we can touch? In the worst case, due to any reason, if there is a path, right, the path will come in either n into m steps or less than n into m steps. There will never be a situation where you need a path in more than n into m steps. If you are requiring, if let's say, if for example, if you just keep on traveling, the moment the approach that you initially suggested, that
So you
I'll
were
just
saying
keep on.
the distance between 0, 0 and the bottom right corner will definitely be less than n into n. Is that what you were
Yeah, the
saying?
number of steps to reach the
Yeah.
approach that you suggested initially, that I'll just go in the direction. So if
Yeah,
you
that
just
makes
go in
sense.
the direction and you count the steps, and you just keep
Ah,
on counting the steps, then at any point of time, if the number of, if you go out of the grid, that's a different situation
yeah.
altogether. But
If
if you
it is
count the steps
if
and,
the number of steps exceed n into m, then we can just stop there. Yeah, that is a very simple solution.
yeah, like that goes with linked list also. But in linked list, you need to know the size of the linked list. Because of the fact we don't know the size of the linked list and we don't want to spend time in knowing the size of the linked list, the tortoise and a rabbit approach exceeds that way better, because then we can just start. But here we already knew the
Hmm.
possible biggest size of the linked list altogether that we are going to extend. So that can be one more approach. And I don't think there is much benefit in terms of time and space of that approach. But that approach is implementation is going to be like
Very easy to implement.
yeah, it would be a cakewalk to in terms of implementation. But
Yeah,
your
yeah,
implementation also looks pretty much good, I would say.
yeah. Yeah, I believe, there was a very easy solution. I overcomplicated like I always do.
Yeah, but
So
I
yeah,
believe thinking it in terms of hare and rabbit also has a good, I would say, technical discussion that we had. That okay, we reached the solution instead of just like coming up like
yeah.
with the solution altogether. We reached the solution. That was a good discussion, I believe.
Okay.
Cool. Okay, so I guess that's a wrap. I believe all those people who are watching the video must have learned about a couple of new approaches and a good temperament that you should maintain during the interview. I believe Pulkit maintained that. And considering the fact that we were coding on Google Docs is a different challenge altogether. I believe he has written one of the most finest and the cleanest solution that I've seen somebody implementing on Google Docs. So thanks Pulkit for giving us your time. And if you guys have any questions, feel free to drop in the comment section. I'll be happy to reply to all of them. That being said, let's wrap this particular video here. We're going to meet soon in the next set of videos. And again, thanks, Pulkit, for coming up. Till then, take care. Bye bye. Have a great week ahead, guys. And I guess that's a wrap.